Akash, I'm Chandrali. So I'll be interviewing you for today. So could you please quickly give a brief about yourself?
Sure, Chandali. I completed my graduation in 2018, and since then only I have been in the data engineering space. So, I have worked on the technologies like Apache NiFi for ingestion, uh, PySpark, Spark, Hadoop data stack in Hadoop like the HDFS, and I have also worked on ELK stack, that is Elasticsearch Kibana stack, where we store the events. Later in my career, I was also the part of Azure Stacks, where I worked in the tech stacks like Azure Data Lake Storage, Azure Database, Azure Data Factory. So these are the tech stacks which I have been working on since around 5 years, and I've been in the retail and in the fintech industries. So yeah, that's about me too.
Okay.
Yeah,
So you mentioned about working on PySpark and Azure as well.
right.
So how are you integrating it? Like how is the pipeline being made?
Our source system. There are two parts where I have been working on. So one is on-prem Spark, and the second is the cloud basically. So in the on-prem, we what we are doing is we are using the ETL tool, that is the ingestion framework, which you call it is Apache NiFi. So
Mm-hmm.
NiFi is a kind of a ETL tool which basically connects with the sources, and its task is to move the data. So we are using Apache NiFi for connecting our sources. So basically for ingesting the data and putting that all the data to the HDFS, which we are acting as a data lake. And from there we write Spark jobs where we pick up the data from the HDFS, do certain transformations, and do certain joins, transformation, optimizations on the data, and again put it back to the HDFS. So this is how we are working. And in cases of Azure, like some of the customers are basically onboarded on Azure. So in case of Azure Data Factory we're using mainly in Azure. We do not we are mainly using Data Factory as an orchestration tool where we are calling the Databricks notebooks, and of course writing the Databricks notebooks on the data which is already present in ATLS. So this is what we are doing.
Okay. So
Yeah,
you mentioned about the on-prems, you mentioned about HDFS. You are bringing the data and then you are storing it back to HDFS itself,
right,
right? So
right.
are you using any data warehouse? Like how are you doing your analytical purposes?
Yeah, so we are using Hive. So basically, like we're creating the Hive tables within the Spark job, within the Sparks, and from there the data analytics teams connects and it prepare the analytics solutions.
Okay, you're creating the tables itself on
Yeah,
Hive. So
right.
what kind of tables are those?
So basically, the external tables, both kind of tables, external tables and the managed tables. So external tables, like it's like a kind of a sales aggregations,
Mm-hmm.
purchase order aggregations. So as I mentioned, as a retail domain as well.
Retail
So
domain.
yeah, so in most cases, like the sales aggregations, which vendor placed how many orders, what was the order amount,
Mm-hmm.
if there were failures, what was the failure. So all kind of data we store.
Okay. So approximately how much data are you dealing with in this on-premise framework? Like what
Uh,
kind of jobs are, I mean, you're writing the Spark jobs, right? So what
right.
kind of jobs are these? Weekly, monthly? What kind of
It's
jobs are those?
mostly weekly.
Okay.
We are taking the weekly, and in some cases daily reports as well. So it's mostly a reporting kind of a job where we are taking the data in the batches and processing it, and then sending it back to the HTTPs.
So how much data are you dealing with in the weekly jobs and the daily ones as
Seven, 70, 80 GB data, around that we are doing. So
well?
we
Okay.
receive around that much data.
Okay. Okay. So coming to that, if you're dealing with 70, let's say 70 GB data weekly,
Yeah.
so how are you configuring your Spark clusters? Like how much resources are you giving? And like if you could give an example, like of a, let's say you said about purchase order. So
Mhm.
let's say for that particular purchase order, you are trying to filter out the failed purchase orders or the past
Right.
purchase orders.
Right.
This kind of a job you have, and you have 70 GB of data weekly. So how
Mhm.
are you configuring? Like based on 70 GB data, can you just explain like the configuration?
Yeah. So like how what are the configuration of the this
Yes, like
Spark
how
job which we are
much,
giving.
yes, how many executors you are giving, how many, like the other, like the memory and the CPU, how much you are
Yeah,
giving.
so basically, we're using a 40 node cluster with the 16 core and 64 GB node and 64 GB memory, 16 core and 64 GB, and we are using executor size of like 5 cores per executor, around 4 GB per executor. So this is the size which we have taken, and accordingly, whenever the data increases or decreases,
Mm-hmm.
we made so we are not using the whole 14 node cluster for a single job. There are multiple jobs, and according to the data which we are receiving for certain jobs, we are making the configurations.
Okay, so you said about 16 cores,
Yeah,
64
64
GB
GB,
memory,
right?
and five, what do you say,
Five
executors
cores per
per
executor.
5 cores
Five
per.
cores per executor. Yeah.
Okay, okay. Okay, so, okay, tell me one thing then. So, with this configuration, how much time does your like each job take?
Like for around like 20 minutes, 20 25 minutes we take
20,
it.
25 minutes.
Right.
Okay. So, is there any chance that you can, possibly optimize the job so it can,
Yeah.
run faster? And if yes, then what are the kind of optimizations you would use as per your suggestion?
Yeah, so we are with this data also we are using multiple joins.
Mm,
So most of the cases, what happens is like what I done is there are multiple joins which was involved. So in most of the cases, like this merge sort join was happening, and that
mm-hmm,
was causing a lot of time. So we have used the SVM joins instead, SVM joins to basically partition and bucketing so that the joins become easier. And in most of the cases, we are able to reduce that time. That is one thing. The second optimizations was using the broadcast join. So, like let's say a certain next a certain table comes up, and we again have to make a join with that table as there are a lot of normalized parts, so we have to make a lot of join. So if, let's say a certain if new small table comes up, and
mm-hmm.
there we have to make joins. So we try to use that. Can you possibly use the broadcast join for joining that particular section, because the second one table is quite small. So we
Mm.
try to enforce the broadcast join. If not, then again using the SVM techniques, or if like let's say broadcast join limit is
So you're
10.
mentioning about the
Yeah,
SVM techniques, right? Can you
right.
explain like how it works and what are the criteria for that you can use that join? So let's say, because what I am asking is, if we
Hmm.
have a small file
Hmm.
and you are joining with another big file, so in that case, as you mentioned, the broadcast join can be done, right?
Right, right.
So why is the sort merge join coming in place?
The reason being is because if as distributed data is present in different machines, right? Now, if the tables are present, if the data is present in different machines, for joining the entire data, one of the machine has to look the data in the entire machines, right? So that it can find the key for joining. In that case, a lot of data shuffling movements are required, and whenever it's a high shuffle movement, it can possibly impact the computing power and can also impact the time, the total time for the job, and
Hmm.
and we can avoid that using the SVM join.
Okay.
And similarly, same we can avoid it by broadcast as well. So in
So how
broadcast,
can we avoid it? Like, what is the technique that is happening in the backend for,
okay,
like, we are trying to avoid that? So what is the
right,
technique that is happening?
okay. So for both, you want me to explain for broadcast and
No,
SVM?
any one
Okay.
of it is fine.
So for broadcast, what we are doing basically is we are kind of hashing a smaller table,
Hmm.
and sending that data to the entire nodes. Now, if one of the data is available in the entire machine, if one of the table data is available in the machine, then for joining the two tables, it doesn't have to shuffle, and it can easily join because the other
Okay.
table data is already present in that machine, so it doesn't have to look for the data in the other machines, and in
Basically,
that
we are
case shuffling
just
will happen.
copying the smaller part
Right,
into the all the other
correct. We can
machines,
say
right?
we are just copying the smaller part to
Hmm.
the other
And
machines.
what about sort merge join?
In sort measure, we are creating the buckets,
Hmm.
and we are creating the buckets and the partitioning. So for each bucket data, the key of one table the record for one table key would be present in the same partition, where for the other table data, the same key record is present. So bucketing kind of ensures that same bucket data are available in same machine, so it doesn't have to shuffle while joining.
Okay.
Yeah,
Now, and I understand from your point is that we want to avoid shuffling, right?
right.
So, like, what is shuffling,
Shuffling
and why do
basically.
we want to avoid it? Like, what does it do that we want to avoid shuffling?
Yeah, so shuffling basically means like two movement of data from one machines to another machines
Hmm.
while doing certain computations or transformations. So whenever
Okay.
it's a movement of data between across all the machines, it would take much more time, and it would take the computation power. So we basically want to minimize that. That's where we want to avoid shuffling.
Okay. Now, let's say I'm writing a Spark job. I mean,
Mm.
let's say you are writing a Spark job, and
Mm.
what is the first thing, or what are the first few things that you should do even before you're triggering shuffling?
Mm.
Like, just think of it. Let's say you are writing a logic where you
Mm.
want to join two tables, but
Mm.
even before, and let's say one table has 500 columns and
Okay.
another table has 100 columns. So you want to
Mm.
join both of those tables.
Mm.
But of course, when we join, that will be a heavy computation,
Right.
whatever type of join we try to use.
Mm.
But what are the necessary things that we can do that even before we go to the shuffling phase that can be done, that can be taken care of?
But many smaller things like removing the non-essential data, filtering
Mm-hmm.
out the non-essential data, making sure that we are what like we whatever, even if we are whatever operations we want to make on a certain table before joining, like let's say we are doing certain operations in the one table and certain operations in the table in the second table, certain transformation in the second table, we should do those transactions or those transformation with very first before we go for joining,
Hmm.
just so that in the final join either the broadcast joins are possible, or even if the join happens, the time itself taken is low. So filtering out the data, it's,
Right.
it's possible. It should be
Right.
done right
Yes,
as soon as
this
early.
is like the the first thing that should be taken, that we filter out as much data as possible
Right, correct.
instead of doing it on the whole data frame.
Whole data, right.
Yeah. Okay. Now, one more question. When I am submitting a Spark job, right,
Mm.
and like whenever I'm saving it in a data frame and everything,
Mm.
there's some partitions created, right?
Right.
So, what are those partitions?
So basically, the logical unit is a kind of a logical partitions where we are each partitions would be acting as a task, which would be computed by a certain executor, basically a certain machine. So
Hmm.
that is the what you can say the smaller unit of data, smallest unit of data, which will be computed by the machine, taking it as a single data. We call it a partition. So let's say,
Right.
yeah.
So that partition will be computed by an executor, you are saying,
Right,
right?
right.
So is it somewhere related to the course as well? Like we are
Yeah,
assigning some course to the executor.
right,
So
right.
my question now is that how is the number of partitions? Because
Mm,
see, we have a concept that we can define the number of partitions. That
mm,
these many partitions I want to assign to this Spark job. So how are this number of partitions related to the CPU course? Like if I, let's say you want to assign like I want to give this many number of CPU cores and I want to assign this many number of partitions. So
mm.
how will you do the calculation? You have got a requirement like this, that this is my data, and according to this, you have to decide that the CPU cores and the number of partitions you have to decide. So how are they related?
Okay, so basically, core itself means like it itself can act as a single machine to handle that partition. So basically, one partition can be consumed by one core.
Mm-hmm.
Okay, so let's say we have a 10 core machine, and we have basically 10 cores, and we have 20 partitions. Then the first 10 partitions would go and would be computerized by cores, and then in the way the second 10 partitions will also get, and will get transformed or computerized basically. So this is how those partitions would be computerized. So one by one core would be taken. One core will take the one partition.
Okay.
Yeah.
No, my question is that, like, how are they? There's a relation between the
Hmm.
number of CPU cores you're assigning and the number of partitions you're
Yeah.
assigning. So,
Hmm.
what do you know that relation? Like, how should they be, computed?
Sorry, I might be missing your question. So when you say how they are
My
how should they
question
be
is that,
computed?
so let's say I have 10 partitions,
Hmm.
okay, and I want to assign the number of CPU cores as well for that Spark job.
Okay.
So, how are
Hmm.
you going to, like, what is the number that you're going to give to that this many CPU cores I need?
It's basically related to in how much fast you want to perform
Hmm.
your job, how critical that job is. If
Hmm.
that job is very critical,
Hmm.
and if I have 10 partitions, I would just assign the 10 course for that particular job. Okay, if that is not self critical, and we can have a little greater time
Hmm.
according to the other jobs, we can assign, let's say, five cores for that 10
Five.
partitions. Then it will take a double amount of time. If
Correct.
if it at all is non-critical itself, we can just assign two cores, then it will take the five times reference. But only thing I'm trying to say is there is no point of assigning 13 cores to a 10 partition job,
Hmm.
because whatever you do, no matter how are the jobs configuration, 3 cores will always be unutilized, because
Hmm.
10 cores can only handle those 10 partitions. It
Right.
will not happen that 10 partitions also get divided into 13 cores and
Hmm.
get computerized. One core would be able to take one partition.
Right. So
Yeah.
basically, like, depending on the criticality of your job, that how much time you want to take for that job. So
Hmm.
it's a direct proportional. So even
Right.
if you are doing 10, right? So it should
Hmm.
be a multiple, basically. That's what I'm
Okay.
trying to say.
Right. Right. So it's a direct proportion. Yeah.
Direct proportion, yes.
Yeah.
Okay. Now, you had mentioned about bucketing and partitioning, that you have worked on it
Right.
in your project. So, can you tell me, like, what are the scenarios when you can use partitioning, and what are the scenarios you can use bucketing? I mean,
Hmm.
the answer I would like to hear is like the real time scenario that you faced, that you could have used partitioning, but you had to use bucketing, and why was that the case?
Okay. So basic reason is, let's say I have a sales data. Okay.
Mm-hmm.
In a sales data, we have a vendor, we have a order ID. Okay. Now when every order ID would be having a different record. So there would not be many duplicates. So there could be some cases of duplicate order IDs, but let's assume that every order is having a unique records. Okay, and now, so if and vendor, we have, let's say we have 1,000 orders, but for that 1,000 orders are from 10 different vendors. So vendors could be repeating and order IDs would not repeat. Correct. Now, in those cases, let's say I want to do a searching on vendor. Okay. Now it makes sense to do a partition, because we have a limited number of unique vendors. So if we give the partitions, in the end, in the final table, the structure that will be created is having the 10 folders for 10 different vendors. Now, if I have to search for a particular vendor, let's say HP. Now, if you are searching for a particular vendor, I would just go in that folder. Like SparkJob would just go in that folder and search for whatever transaction is needed. It doesn't have to check the other vendors. So in
Hmm.
this case, the partitioning is really making a sense, because it doesn't have to search the other folders.
Hmm.
Now, let's say I want to query on order ID. Okay. Now, in those cases where we are querying or joining the order IDs, it, if we create partitions, then for every order ID, different folder would be created. And even if you want to search a certain order ID, it has to go again and again in the folders, because now every folder will only contain one record. So it doesn't make sense, and it's not beneficial as well. So when we have many, what you can say, non-unique rows, in those cases we use bucketing, where different it uses a hash function, and kind of group the order IDs into one of the files, order ID records into one of the files. And when we have a certain number of key, like just like I gave the example, right, as vendor, right. Now we have only 10 vendors in a 100 record file. So if we have a limited number of unique value for that particular column, we use the function.
Okay.
Yeah.
So you mentioned about hash function.
Right.
Can you explain what is hash function?
Yeah. So basically, the hash function is let me explain. So let's say we are taking it as a modular function, as a hash function.
Mm-hmm.
So, so hash function is a unique way to just identify different transactions in one. So let's say if I am taking a modular function of 4, now if four order IDs are there, 1, 2, 3, 4, now that for first order the hash value will be 1, for second order the hash value will be 2, third it will be 3, and again for 4 it will be 0. So basically here the hash function is the reminder. So for fifth order ID, again the hash value will be 1. So the first and fifth will be kept in a one group. Now whenever a new transaction comes for querying, now we know which bucket to access, because the hash function will just find the modulo, the reminder, and now the bucket will be identified. And now we know that okay, we have to search this in this bucket only. So it also helps in querying this hash function. So kind of a way to differentiate the different data points into the one unique set basically, so that the querying becomes easier.
Hmm. So you mentioned about the modular function in this case. Do you
Right.
know what a hash table is?
Uh, yeah, so basically like kind of a pointer to a certain set of data,
Mm-hmm.
that is the hash table. So here, if I talk about my example, the hash table I'm talking about tag word is like for one, the hash table would contain the record ID as 1, 5, 9. So these are the records which would be pointed in a hash table for the modular result one.
Okay.
Yeah, yeah, kind of a pointer to the set of records, you can say.
Okay.
Yeah,
So, if you have you worked on Python? Any,
yeah,
so you will have understood like what is a dictionary, right? How the
right,
dictionary works, key value
mm,
pair.
correct.
So, the hash table, what you said is correct, but
Mm,
like the basic thing what a hash table does is that if you see the key value pair, right? So
mm,
there's a key, like let's say one, and there's a value for it.
right.
Similarly, there are like iterations of the same data.
Mm,
So a hash table is basically, it's like a table where all of this data is stored.
yeah, right.
Okay. And there's an
Correct.
index for it as well.
Mm,
Right. So now have you heard about collision handling in hash table?
no, I haven't. I don't know.
Okay.
Yeah.
Okay. So there, I mean, here comes the another concept as well. So what like collision is basically like when you have the, you know, different indexes having the same key or the
Mm,
same value. So there will be a collision, right? Because
right.
two indexes will fight among each other that don't know this is my key, no, this is my key.
Mm,
So there comes like this hash table has this problem that there's a lot of collision handling, I mean, lot of collision happening. So
mm,
for that, we use some techniques like collision handling as
oh,
well. Okay. So just like if you could spare some more time on hash function and hash table. So modular function, I totally understand it's fine, but there are
mm,
different other kinds of hash functions as well. Okay.
okay. Yeah.
Yeah. Okay. Okay, so we were talking about partitions as well, right? So
Mm,
let's say you want to decrease the number of partitions. Okay, you
oh,
don't know, you do not need. Let's say you've your job has. Okay, one more question. So when you use joins, there's a
mm,
default number of partitions created. You know what's that? How much partitions is that?
mm, whenever okay, so, 200 is the I guess
Two
that
hundred.
number. Right.
Yes. Now let's say I do not want those many number of partitions because when I use so many partitions, there might be cases for like some partitions are blank. It's not
Mm,
doing anything, right?
right.
So I want to decrease the number of partitions.
Mm.
So what are the things that I can do?
So we have this property which we can set default shuffle partitions.
Mm-hmm.
So we can use that property directly in our code to set it up. That's one thing. Second thing is we can enable AQE. So if we are above Spark 3.0, we can enable advanced query
Mm-hmm.
optimization AQE, and if we enable it, it will automatically remove those partitions.
Okay. Have you
Yeah,
heard about like coalesce and repartition, which you can do manually? Like,
yeah,
what
we
is the
can we can
difference?
do that as well.
What is the
So
difference between coalesce and repartition?
So basically, like in Coalesce, first the partitions which are available in the same machine get kind of compressed and reduced, and then the shuffling happens. And in repartition, all together shuffling happens. So it is
Oh,
always advised to use Coalesce in case of reducing repartition.
and why is that?
because the number of the reducing will happen within the
Mm-hmm.
machine itself, and then if needed the shuffling will initiate. So again, to reduce the shuffling.
Okay. Now
Yeah.
coming to this point, let's say, do you know about data skewness? Like
uh,
there's a thing called like
yeah,
partition skewness.
yeah.
What happens in that data
So
skewness?
in that case, let's say we are anyway, whenever we are performing any wide transformation, if a certain key, not the wide transformation, but let's say we are performing certain aggregation like group by, okay. Now let's say for a certain key the records are quite high, and for other key the records are quite low. So all the records with high volume would go in same partition,
Mm-hmm.
and it would kind of create a problem because we want data to be distributed, right?
Mm.
We don't want all the data to be in the same partition, but all the requests would go into the same partition, and that would kind of create a problem. It might take a lot of time. It might cause a memory issue.
Mm.
So that is partition skew.
Okay. So
Yeah.
what are the ways that you can solve partition skew?
Yeah, so basically, if we are using earlier versions of Spark like before 3.2,
Mm-hmm.
we can use the sorting technique
Mm-hmm.
within the Spark. And if we are above 3.0, we can directly enable AQE, again, the same thing, which will solve this partition skew problem as well internally. So internally, it will use sorting only, which is
What does
basically
salting
like,
do?
yeah, basically it will just append if we have a key. So let's say we are grouping on vendor. So let's say we have HP as vendor. Now it will just add a certain number of keys before the grouping, before any kind of grouping transactions, and in that case different keys would go in different partitions. So let's say we have this HP as six records worth with HP. Now three record will go as HP1, two other three records will go as HP2. Now in that case, when the grouping will happen, HP1 will go in one partition, HP2 will go in second partition. Whatever grouping is needed will be done, and then later it would just rename HP1 and HP2 as HP. So kind of we are able to solve our problem as well, and it doesn't impact the final result as well.
Okay.
Yeah.
What are the kind of, okay, let me give you a scenario.
Mm.
So, let's say talking about this data skewness only. Okay.
Okay.
So, let's say my job is running like very slow. It's taking 1 hour to complete.
Mm.
And I debug it and I see that one of the partition is holding like 90% of the data
Right.
due to some reason, maybe the code of the job or some reason something has happened. So the partition is taking 90% of the data and the rest of the data is going to two partitions. Let's say I have 10 partitions, so one is taking 90% and the rest 10% is going to three other partitions, and the rest of the data is, I mean, rest of the partitions are blank
Mm.
completely. So
Okay.
my job is taking a like very long amount of time.
Mm.
So in this case, let's say I have the leverage to use coalesce or repartition, either of the two options. I'm not considering other things as right now that what I can do. I'm considering like coalesce or repartition I will use. My senior has said that you can use either of the two. So which one will I use in this case?
Okay, so you were saying that one of the partitions is having a large amount of data,
90% of the data, everything.
90%
Yeah.
of the data. Okay. Uh, and other two are not using that much data. Uh,
No. So let's say total I have five partitions. Okay. So one partition is taking 90% of data. Two partitions are taking 5%, 5%. So three is done. Rest of the two are blank. It's not taking
okay.
anything.
Okay.
So
Okay.
I mean the huge data skewness. So
Hmm.
which one do I use in this case?
I don't think that whatever you use repartition and coalesce,
Hmm.
it would change the scenario until we use AQE or
Let's say we
sorting.
are using AQE, but
Yeah.
what I'm trying to say is that I want to understand that how repartition will work in this case, because we had mentioned that repartition will do a full shuffling,
Hmm.
right? And
Hmm.
coalesce will just take out smaller pieces and it will try to combine data and it will
Right.
try to make equal partitions.
Right.
So if I have this either of these two options, which one
Okay.
should I use so my this scenario is solved?
I think we still need to use repartition only because in this case
Hmm.
we would
Full
increase the number of,
shuffling.
yeah.
Yes.
and full shuffling as well.
Right.
So yeah,
So that is what. So
yeah,
it's like it's scenario based, right? Either
yeah,
of the
yeah.
two, it's totally scenario based.
Scenario based is scenario based. We
Okay.
cannot use one in every case.
Yeah. Okay. So you mentioned about white transformations, narrow transformations. Can you give some examples that you have worked in, your real time project?
So by transformations are like basically we I've used group by. So mostly whenever we are using the group bys, doing some aggregations on those particular keys that are the by transformation, and to give a very minimal basic example for narrow transformation is filtering.
Mm-hmm.
So yeah, so that would be the narrow transformation which we have
Okay. Can you tell me about like how many stages would be incurred if I
used.
use one white transformation? Let's say I'm using reduce by key. So how many
Okay.
stages will be incurred in that job?
For whenever we are adding any of the Y transformation, one stage for that transformation will be created. Additional one stage.
So
So
total how
let's
many will be created?
so for
I have
reading
used
one,
only one white transformation.
two would be created.
Okay,
Yeah.
it's n plus one, right?
Right.
Number of white transformations plus one.
That's right. Right.
Okay. Now, how many? There are three things, right? Tasks, stages, and there's the full job. So,
Right.
how many tasks will be created?
Uh, so whatever are the number of partitions for that
Hmm.
data, that many tasks will be created.
Right.
Right.
Okay. One more question is that why is Spark considered as lazy? Lazy. We have one. You will have you heard about it, right? Lazy evaluation. Why is it considered as lazy evaluation?
Because it doesn't perform the actual transaction until any certain action is being come as a command. So
Mm-hmm.
let's say I'm using filter, let's say I'm using filter. Whatever I am doing, it will just keep a track of it until we actually write a action job. So action would be, let's say we are doing a count, we are doing certain show. Maybe we are trying to do on a gateway on show just to check the data. So it will just keep the track of all the events until the final action is triggered. Uh,
Okay.
and that's why we call it lazy. Okay, it's being
Okay.
lazy on evaluating the transaction. Yeah,
Got it. So have you used RDD as well?
a little bit in certain cases, not much,
Okay.
but yeah.
So what do you find like as per your as per your opinion, which one do you find better and why?
For me, because most of the cases we have to, the most of the cases, the higher data frames that are like non-RDDs, the data frames, Spark SQL, it's a lot of functions are there, a lot of optimizations are there. So I find it easier to use them, the higher data frames. But in cases where we have to go granular and certain jobs are not certain transactions are not supported by data frames, we might go to RDDs and do the transaction. But personally, if a job if a job can be done within the higher level API like the Spark SQL or the
Mm-hmm.
data frames I really prefer. But if it can't be done, then we can go to RDDs.
Okay. So what are the optimizations? You talked about some optimizers which are used in the higher level ones. Can you name like have you do you know about any one of them?
So like one of them is could be like the catalyst optimizer, right? So let's say we are a very basic example. Let's say we want to multiply all the columns. We have a set of columns which are integer based. We want to multiply it by one. Now there are some inbuilt optimizations which it follows. Spark follows. Okay, it will not even initiate the transaction because all the columns are all the data points are being multiplied by one, so it doesn't make sense. So it will without even computing, it will give us the same result. So
Mm.
these are the certain things, and then we have many like physical like we have certain at the time of joining, at the time of doing certain operations as well. Certain optimizations are used while finalizing the physical plan, while doing which joins to follow, which join not to follow.
Mhm.
It kind of optimize internally. So
Okay.
that those cases we could do.
Okay.
Really useful. Yeah.
Okay. So I'll ask last two questions and then we'll move to a sequel. Okay.
Sure.
So one question is that have you ever faced out of memory error in any Spark job?
Yeah.
And
Yeah.
if yes, then how do you first number one debug it? How do you understand that what is happening, and then how do you resolve it? So if you can give like a real time experience or example like which you faced.
Yeah. So out of memory error mainly first of all we can capture it. We can see that in this Spark UI. So there, if certain task is not performed at all, we have certain errors within that particular executor. We can check it there, and you can see the disk spelling and certain things in cases of out of memory error. So in most of the cases which I have faced, the out of memory error is happening because of the driver memory. So because of
Hmm.
the driver memories. So in those cases, either we can check, okay, have we done certain transactions, like broadcast join would be one of the examples. In broadcast join, it's the driver task to copy the entire data to the
Hmm.
different machines. So we have to ensure that whatever we are broadcasting, it should be less than the driver memory allocated. So we can either reduce that broadcast or we can increase the driver memory
Hmm.
based on the scenarios. So yeah, we can resolve it in those cases. And other cases could be the simple one like let's say for every partition for every core around 1 GB is being allocated
Hmm.
execution memory, and for one partition because of this group bias or the aggregate function, the one partition size is coming as 700 and 800 MB.
Hmm.
It can happen, right? Now if 800 MB 900 MB data is there, it might need more memory to do that particular computation for that particular partition. So in those cases also out of memory can happen. Then in those cases we might try to increase the size for every partition and which is being consumed, and in those cases we can remove the out of memory.
Okay.
Yeah.
Okay, so first thing basically you will need to see that where the memory out of memory has
Yeah.
occurred,
Right.
right?
Right.
Is
Right.
it in the driver or is it in the executor?
Execute. Correct.
Because there is no point looking into the executors if there is a problem in the driver itself,
Yeah. Yeah. So we have to
right?
check in Spark UI
First, you
where
have
it
to
is coming.
check that where it is
Right.
coming, and then you
Right.
need to debug as per that, right?
Correct.
Hmm. So another thing is there you must have heard like let's just give you a scenario. Let's say I have two files, okay,
Mm.
coming into HDFS. One file is of let's say 10 GB and
Mm.
another file is of 20 GB.
Mm.
Okay, I have two files. Now I want to join those two files.
Okay.
Okay, I will write a join and all of that. Now, what is the I mean, see, when I write the Spark job, as we had already discussed, that there will be some partitions which will be created, some number of partitions, right?
Right.
So, how, as per this configuration, like 10 GB and 20 GB, both the files are there. So,
Mm.
how many partitions do you think you should assign so that your job runs fine?
Okay. And okay, got you. So if we have 10 GB, that would do some certainly means 80 partition for that
Hmm.
10 GB, and for 20 GB we have 160 partitions.
Hmm.
So the total number of partitions which we will be handling is around 160 and 80, 240.
Hmm.
And now for these 240, if we want them to be if you want them to be performed very quickly, you would
Hmm.
assign 240 codes, which would, if I just reduce that down, so it would again be like 5 cores per executor. So
Hmm.
somewhere around 240 divided by 5, which
Hmm.
is 48 executors basically. So if you want it to be a full speed, we will assign 48 executors.
Okay. So the reason I'm asking this question is there can be scenarios. So what is the default like block size? Uh,
128 MB.
128 MB, right? So there can be scenarios where you do not need those many partitions. Like you have analyzed the whole job and your code and everything, and you see that you do not need those many partitions. Anyway, you have this large files which is coming, right?
Right.
So as per Spark default or Hadoop default, it will like one divide by 128 and it will create those number of partitions.
Hmm.
So there can be scenarios that we can increase that
Right.
block
Right.
size for that particular case, right? So
Right.
so that we get like logical amount of partitions, right?
Correct.
Because it cannot be the case that let's say we have 100 GB file and we have like 1,000 partitions. That cannot be
Mm.
the case, because with partitions other things are also getting hampered. So
Right.
have you faced anything like this where you needed to increase the file size? And if yes, was there any case that you have faced small files issue, like a large number of small files were created?
Yeah. So basically, this whenever we need these kind of things, like where we have to increase the size of a partition. So what we can do is basically we have used like I told like examples for coalesce, where we are
Hmm.
just reducing the number of partition. If we use coalesce, if we use repartition, then we can by using these we can reduce the number of partition, which basically means like for one partition we are getting a more data. So by doing that we can achieve this. Second
Hmm.
thing is related to the small file problems that we have actually faced it, but that is more in cases of Azure Data Factory. In cases of Azure Databricks notebook, while executing those Databricks notebooks, we have faced this issue. So there we have Azure Database gives a option of optimize command, so we can actually use optimize on certain data tables, which would do what it will do is it should just combine the smaller files into the one file, and now this would not cause many issues. But the thing to note here is it doesn't combine all the files into the one file. It will
Hmm.
combine to a certain limit. Like in by default, is in the database it combines until 1 GB. So
Okay.
if a file is filled with 1 GB, it will again create another file and try to combine the smaller files.
Okay. Have you heard about compaction?
Compaction? No, I haven't heard.
Okay, it
Uh,
does a similar thing, like it
okay.
combines smaller files into bigger files. So smaller file issue can be solved with this kind of things.
Yeah.
Okay, one last question is that you talked about ADF, right? You talked
Mm.
that you were working on ADF. So how are you scheduling your jobs, the weekly ones or the daily ones, like both on-premise and your cloud? Because you mentioned in on-premise also you have weekly jobs. So how
Yeah.
are you scheduling them? What kind of orchestration tools you are
We
using?
are using Apache NiFi where we are
Okay.
triggering
And for
the
the ADF,
jobs. For yeah, here there we are using like in cases of Azure Data Factory, mostly it's the storage based event triggers. Whenever a file comes,
hmm.
we are processing it. So
So you
we
have
are
event
using the
triggers,
event, yeah, event triggers in the ATF storage event, in some cases the schedule one as well. But yeah, we have this event triggers.
Okay. And have you worked with like time triggers? Have you worked with cron?
Yeah, so there also we have said that in
Okay.
prawn we have basically used in Hi-Fi.
Hmm.
We are just writing the prawn expressions to trigger the Hi-Fi jobs, which will
Okay.
trigger this part.
Got it. Okay. I'll just paste a link. You can just access and you will see a SQL question.
Okay,
You can just try to solve it. Even if not the exact code, you can the pseudo code, and if you can just explain, that would do. Just see if you're able to access it.
now just, uh, I've just sent you the request to access.
Okay. Can you check now?
Yes.
Yeah.
Yeah. So we want top two customers every month with highest sale, right?
Yes. So basically, if you look at
Mhm.
January, there are two entries for the ID 100, right? So that will be summed up. So ID 100 will have 500 cells. Okay. So for
Okay.
January, the top two customers will be 100 and 102. Okay, 500 and 400. And for February, it will be 103 and 105. So to both the months, so basically my output should be customer ID, month, sales. If you do not give, that's also fine. But ID and the month, like separately. January will have this two, and February will have this two. And
Okay.
also, if there are multiple entries for the same ID, it will do a summation.
Okay. So what we can do is we can first group them like on the basis of ID,
Hmm.
on the basis of IDs and month. We can have a we can just find what is the total sales, and then using the rank function, we can find using the window function, we can find the total response.
Yeah, just try to write the
Yeah.
syntax.
Yes. Do you want to find it top two, right? So,
Hmm.
all that. Okay. So, everybody do that. So yeah, we can do that. So this would first find me the first find the total sum sales for a certain item for a certain month. So this CT value would contain basically contain the columns like the ID, month, and sum of the sales.
Yeah,
So
understood.
for
So
100
can
sales,
you
it
tell
will
me the difference between rank and dense rank? Like, why did you use dense rank and why not rank or row number?
so basically, rank would skip up the earlier values. So let's say we're going to find the top two customers,
Mm-hmm.
and if two of them are having the same value, so the rank would basically skip the second rank. So it will just put first two sales as 1 1, and the third sale as rank as 3. But the dance rank will give the rank as 2, and we want the top two, right? So that case
Hmm.
we are using the dance
Correct.
rank. And row number, it will just assign 1, 2, 3, 4. So it doesn't make
Hmm.
much sense to use.
Doesn't make sense. Right. Okay. Can you tell me? Okay, one question I will give.
Mhm.
Okay. So let's say I have a simple case when. Okay. So okay. So what will be like for the first case and the second case? What will be the result? Like true or false?
check. So, first case it would definitely be false.
Mm-hmm.
Second case I'm equal to null. First case is false. I'm not sure if the null comparison happens, how it happens within the SQL. If it happens directly this way, then it would be true. Otherwise false. So I'm not sure on the second one if it would be able to compare the null with null. But the
Okay.
idea with case statement is if left is equal to right, if that's this particular condition is true, then whatever value it is, just assign this value as result. So true is result here. And in second case, I'm not sure if it can just compare these two values, then it should be true.
Mm-hmm.
Yeah,
Sure.
yeah. I'm not sure in the second case.
First case will be true.
First case, no. First case would be false because
False. Okay.
we are equal to null. Like,
Why will be false?
because it's not equal to null. Right? How two will not be equal to null? Then it is false.
Okay. Yeah, actually the thing in SQL is any kind of any application you use, we cannot do null comparison. Like two, the
Okay.
first one is also like it's false. It's a
Okay.
trick question actually. It's false.
Okay.
Okay. So any kind of like even if I do like two equal to null, one equal to null, anything, it's false. Null
Okay.
comparison is not allowed. Okay. Okay. Uh, one more. Okay, I'll just try to check your joins that how you are at. So let's say I have a table column A. Let's say I have a table A and I have one, 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 two, two. Okay, and I have a table B. So one, one, two, two. Okay, tell me the output of uh, inner. Like you can give me the count as well, like total how
Okay.
many rows will be there.
Okay. So for um,
Yeah, 1 second. Okay, these three will be should be fine.
okay, so for inner join, for these three rows, 3, 6, regular will be 6, and we have to be there for right join, right? So 6, 4, in the places will and this, 3, yeah. And same in case of left join. In all these cases, it will be 10 only.
Okay,
Yeah.
can you explain?
Yeah, so this let's say we're doing the inner join, right? Now
Hmm.
for this inner join, we want to find how many keys are present
Hmm.
for in the other column. So for one there would be two keys. For second row there would be two. For third row there would be two. So total combines up to six. And same for two will be two rows, which is eight. For second row it would be two rows, which is 10. So 10 would come out.
Okay,
Same for the right join. If we want to compare every key in this element with every key here, so 10 will come up. And there is no key which is non-matching, so none of the additional key will come up. Same with left join. There is no
okay.
key in the left which is
Now
matching.
let's say I have an additional. Uh, I have an additional. I am putting a three over here. Okay.
Mhm.
Now.
If you put additional three, inner will not change. Right will also with right will also not change. For left, we will have one column with 11.
Got it.
Yeah.
What is the difference between a semi join and sorry, uh, semi join and anti join? That was the name. Yeah.
I'm not sure on the semi joints.
Okay. Anti
Yeah,
joins.
same. I'm not sure of cross joint where we are crossing the each row it is alone.
That's called Cartesian product.
Yeah, yeah, that's not on semi-join generation.
Okay.
Yeah.
So basically, you know about the right join, right?
Yeah.
So what is a right join?
So basically, in case of right join, it will try to match each row of right column to the left column. If it finds, it will just give us the result. If it
Hmm.
doesn't find that, it will also include in the result. But whatever left column is there, it will just mark it as null.
Null, right?
Right.
So now what semi-join does is, so basically from the left table
Hmm.
that match with rows from the right table. Basically, I'm talking about left join now. So
Okay.
semi-join is basically left join, but the things that have unmatched with the ones from the left will have null, right? But in
Right.
semi-join, that will not be included.
Okay. Okay.
Okay, and anti is like similar concept, but with right.
Right. Okay.
Just go through it once, you will just
Yeah.
understand.
Yeah.
Okay. Okay, I'm more or less done with this. Just one thing I want to check is a Python question.
Okay.
Okay. And also, you talked about you worked on Hive. So, do you know what is the difference between normalization and denormalization in Hive?
Yeah, so normalization basically means breaking down the tables into smaller tables
Hmm.
to avoid the storage issues, avoid the duplicate data.
Hmm.
Uh, and denormalization are yeah, combining the smaller tables.
Okay.
Yeah.
And like, what are the advantages of using denormalization over normalization in Hive? Because
Uh,
you
yeah.
would have known that denormalization is preferred in Hive, right? But what is the advantage of using that?
What advantages is in normalization.
Denormalization over.
Denormalization we do not have to, since being a data warehouse, the analyst teams, we don't want to do multiple joins and to create a final query. So in Hive, in general, not in Hive, but in general data warehousings, we prefer to use another technique that is fact and dimensions.
Hmm.
And basically, we want to have a table where all the measurable values are present so that it doesn't have to do a lot of joins to get the final data and so that is the advantage. It doesn't have to look
Got it.
around all the tables and do the
Got it.
joins. Yeah.
Okay. Yeah, I have pasted a question for. Can you scroll down once? Yeah. So
Mm.
basically, you have to do it both in Python and PySpark.
Okay.
Okay. Like you see, there is like AA, so 2,
Mm.
BB2. So A will, I mean, what I want the output is like A2, B2, C2.
Okay. Let me do it in Python.
Sure.
As I'll create a dictionary. And, because it is presenting that dictionary. Then we use got able to just do this one.
Mhm.
So I can see. Yeah, this would give me the result. For this dictionary will contain the result, which
No, I have understood. Just print it out. Just do
uh,
a loop and print it.
yeah. So this in this loop is dot and yeah, I think it will give me maybe I can do this or
Yeah.
it's recording.
Because I want to know the items, right?
Yeah. Instance and
Got it.
the keyword.
Mhm. And can you do the same thing in PySpark as well? Like, let's consider this uh, I mean, this is a list, so you have to like create a table, like a data frame, and then
Okay. Yeah, I can. I can do that. So, okay, so this could be done in RTK as well, and this could be done in register.
Any.
No, so, uh, also quick give me the result.
Understood. Got it. Okay. It was really nice talking to you. And
Yeah, same here.
yeah, have a
Bye.
nice day.
Yeah, yeah, you too.
Yeah.
Bye.
Bye. Happy weekend. Bye.
Yeah. Bye.